Hello everyone, and welcome to today's webinar with Keith Chambers from Schneider Electric Software. He will be talking to you today about digital transformation in manufacturing. There will be time for a Q&A at the end of his presentation, so if you have any questions, please use the box below the slides and we'll get through as many as we can. You can also use this box to let me know if you're having any technical issues at all. With that, I'll hand over to Keith for the presentation.
Thank you, Josh. This is Keith Chambers. So good afternoon to everyone in Europe. Welcome to the webinar. So we're talking today about digital transformation in manufacturing. But before we jump on that topic, just by way of introduction, I'm Keith Chambers, work with Schneider Electric, actually Schneider Electric Software. And I put a slide up on the screen just to kind of give you an overview of who Schneider Electric is as a business. Global specialists, energy management, automation, and infrastructure offers around the world. Obviously, a large multi-billion-dollar corporation. I specifically work in the software business, so Schneider Electric Software, and you can see some of the specific numbers around our business. And basically our portfolio kind of condenses down into several kind of key offer areas, HMI SCADA, operations management software, design and simulation. And that's really at the forefront of the digital, I'll use the term digital transformation, that's kind of sweeping a lot of manufacturing industries today. So on that note, just to talk a little bit about kind of the offers that we have, the products that we sell. We talk about this in the context of an industrial software platform, and we really see that platform as providing capabilities across the spectrum, firstly for assets, so everything from the design, engineering of the asset, process, design and simulation, its control and information. This is the traditional HMI SCADA space where we have our brands such as Wonderware, and then asset performance, which is the maintenance and support of that asset through offers like enterprise asset management, Avantis, asset performance management offers such as Prism, and that makes up what we call the asset cycle within a plant. There's also what we call the operation cycle, which is capabilities like planning and scheduling across the value chain for our customers, again, intersecting with the asset cycle in that control and information space, and then moving down through operations and optimization. And as we talk about digitalization and digital transformation for manufacturing, it actually does touch on all those different 5 areas of the portfolio. So, one last slide and then we'll move on to something might be a little more interesting than just some details of Schneider Electric Software. These are just kind of some of the numbers around our business. So obviously, leading player in industrial automation, industrial IoT, which is an enabler of digital transformation. We have over 2 million licenses in our installed base, well over 100,000 sites deployed worldwide. You can read the numbers there. Key brands, I don't think we put the brands on there, but you'll know us through the SimSci brands, the Wonderware brands, the Avantis brands are the core parts of the offer that we have. All right, so having gotten the little commercial out of the way, let's move on and talk about what is digital transformation, what are some of the trends that we see happening in manufacturing today, how technology is enabling some new value propositions, what the solutions may look like, and then a little section where we'll talk about kind of the digital transformation journey that we see our customers going through and what some of the aspects of that may be. So I wanted to start out with just a little bit of semantics. Everyone likes to talk about digitalization, and really digitalization this is a dictionary definition of it, a conversion of text and pictures sound into a digital format. In and of itself, there's some value in this. So this is kind of paper under glass, if you will. So taking something that we do in paper today and implementing it in a computer system, and there is some value and some productivity and efficiency you can gain by that. But what's more interesting is the second term that I use there, digitalization, which is kind of the application of digital technology to really change how you execute your business model. And that's really where the drivers for digital transformation come from. Is not just to kind of carry on doing the same things that we do today and do it on a computer system, but to really drive forward and continuously improve, transform, and change what we're doing, adopt into new business models, new markets, new products, to engage customers in different ways. All of those things are really kind of driven by the use of digital technology, but not digital technology in and of itself. So I'll provide an example here. It's a pretty well-documented example for farm performance. So what I'm showing on the screen there is just maybe a typical workflow that might happen when a machine were to break down. There's a number of people, obviously, that need to be notified. So maintenance needs to look at the machine. The planner needs to know if the machine's going to be down for a period of time. If there's maintenance work that's required, then technicians need to be assigned to go and do that. So there's a lot of kind of parties that are touched. And for one of our customers, which was New Belgium Brewing, that was a somewhat of an onerous process. And so New Belgium Brewing, for a European audience, they're a very large craft brewer here in the U.S. They make Fat Tire, which is a Belgian-style ale, is their kind of marquee product. And they operated, at least at the time, out of a single large brewery in Fort Collins, Colorado. And one of the problems that they had was that they were constrained by their ability to package the beer that they produced. And this kind of perplexed them because the most they had ever been able to produce out of the plant was 150,000 cases through their packaging hall. But yet when they did the calculations around the capacity of all the machines they had, it was more like 220, 240 cases a day was their theoretical output. So they were stuck with less than 150 cases a day for the most part. They were struggling to fill demand, and so they're considering investments in other or in additional equipment, additional packing house to try and bring them the capacity that they needed. They embarked on a digitalization kind of initiative around performance management, OE. They applied some of their technology in there, and they got a really stellar success. As you can see there, they went from 150,000 cases, which was their best day ever, to consistently being able to produce 200 cases on a regular basis. And the impact of that is, you can see that's a 30% increase in throughput that they were able to achieve. So a great success story, very well documented. But interestingly enough, and the reason I talk about this example is it really illustrates the difference between kind of digitization, just applying digital technology, versus digitalization, the use of that technology to improve the processes and the work that's done, and bringing in digital transformation. And when you dig into that example of New Belgium Brewing, you'll see that while the technology was critical as a basis, any transformation is really based around people, processes, and technology. So as a business, we provided that underlying technology, but what became immediately apparent to them as they started to use the system and analyze the data that they were collecting was that, firstly, they didn't have enough maintenance people on site to be able to respond quickly enough to downtime incidents that were happening in the packing hall. So they brought more maintenance people on per shift. So that's kind of the people aspect of the transformation. They also trained up a group of people, employees within the brew house as green belts, and implemented a continuous improvement program to really start to use the data that they were now able to collect and had within the system around targeting bottlenecks and targeting process improvement. So this example, and again, great result, 30% increase in throughput, really was driven, like I said, not just by technology, not just by digitization, but by digitalization, taking that technology, taking people and improving the processes that they worked with to affect that digital transformation. So that brings me to the next point around a digital maturity model, and I kind of show it here in four blocks, and most customers fall somewhere within this kind of spectrum or within this model. Some customers are very opportunistic. Some are applying technology into their business, like I said, essentially replicating what they do on paper today with a digital system. Others are really looking at this as from a process improvement perspective and trying to drive improvements into their operations. And then finally, at the most mature level, you have digital transformation. And digital transformation is typically something that's not driven particularly in the plant. I don't think I've ever met a customer who's looking to do digital transformation only in their operations. So generally, digital transformation is kind of a top-down. And when you look at the characteristics of the various stages along this maturity model, you can see that kind of gets reflected at the lower end. There's no consistent strategy that's going. It's very optimistic. As a business or a company matures, they start to develop more of a company-wide strategy. And when they get to the digital transformation stage, it really is a cultural thing that's kind of driven down into the business and really is targeted as business goals, not just at operational improvements. We're often also asked about the relationship that we see between digitalization, big data, and analytics, and those three things do kind of go together. Again, we showed this kind of on the screen here. As you look at the use of data within the plant, as you become increasingly sophisticated from a digital transformation perspective, so your ability to leverage the data that's being collected improves or increases. And you can see the various stages that we lay out there. So starting with real-time analytics, so a trend chart in HMI screen, for instance, historical analytics, looking at historized data, big data, and giving visibility and insight into what's happening. That's historical analytics, looking back. Then predictive analytics, which is really starting to look forward, which is looking at the data that's collected, applying some advanced machine learning, pattern recognition, other types of technology to predict what might happen in the future. And then finally ending up at what we call prescriptive analytics, which are really analytics that kind of close the loop back to the plant. So not only to say kind of here's that there's an operating condition that's going to move out of specification, there's going to be a failure or something that we can predict in the future, but to also start to prescribe back what needs to be done at the operational level to mitigate against that, such as this particular product that we're running through a packaging line, for instance. We know traditionally that we need to run the line slower, so we have less jamming, for instance, as an example of prescriptive analytics. So that's kind of how we define digital transformation, look at digital transformation. Looking at some of the trends in manufacturing today, and I like this slide because it's a little startling. By 2050, which seems a long way out, but the world's going to be a very different place. If you look at demands for water, there'll be a 50% increase or need for water. There's already water deficits in many parts of the world today, so that we can expect that to become worse. And bear in mind that 70% of the fresh water supply in the world today actually goes towards agriculture and raising food. So when you add kind of the water deficits that we have or can anticipate, and you look at the growth in world population, that adds up to kind of an alarming picture from a commercial perspective. Raw material price volatility, so as demand increases, so prices and other market forces will come into effect. Double 200% increase in demand for energy. Again, similar to water, there's a lot of places in the world today that are energy deficient. As economies mature, people gain more access to power and so use more power. less land dedicated to farming, and the one that always gets me is the last one, is 30% food wasted. So 30% of the food that we produce is actually not used. So that can paint a kind of a startling kind of grim picture. And when you look overall at the trends in the markets that we see today, I really kind of put them into three big buckets. There's demographic changes. Certainly population growth is a long-term trend, but there's other demographic changes that are happening today on a much more short-term basis. Things like the rise of the global middle class in Asia Pacific. So by I believe it's 2022, well over 50% of the world's global middle class will live in Asia Pacific. That's not the case today. So with that kind of shift in affluence in that region of the world, given the size of its population, that creates some tremendous changes in demand and consumption patterns for food, drugs, medicines, all sorts of consumer products. Sustainability, obviously, I think the slide I used before kind of highlights that. Water, energy, our ability to produce more food out of less croplands. All of those things kind of drive a fairly near-term focus around sustainable production and manufacturing. And then finally, consumer expectations. As we as consumers get more educated and more informed, so our expectations also go up as to the healthfulness and safety of the products that we use or choose to buy. Those trends really drive a number of different kind of market forces, if you will. Pressure on margins. Margins are traditionally very tight. Much greater need for variety. You can no longer get by kind of making your one version of the one product that your company made and expect that to be a vehicle for growth. So variety is a way of life now for manufacturing. Excuse me. Regulatory compliance. No shortage of people who are dedicated to overseeing and protecting the environment, personal safety, our health, those things. All of those things reflect as regulatory obligations to manufacturers. Capital expenditure. Capital is always a constraint, particularly when demographics drive investment in other regions. So we're talking at the moment in Europe, while there's still greenfield plants that get built in Europe, the majority of them, as I alluded to earlier, the majority of them are actually getting built now around the APAC area to service that regional growth in demand. So that makes capital very tight. And then the need finally to respond rapidly to consumers, whether you're in food, drugs, cars, whatever part or sector of manufacturing that you may be in. If there's a significant consumer issue, particularly one relating to customer safety or health, it's very, very important to have the information and to be able to communicate rapidly and effectively with your customers to minimize the potential impact for them. So those are all kind of market change, the market environment, and I've shown that on the left, and that drives what I call customer imperatives, or the business outcomes that manufacturers are looking for out of digital transformation. So improving the performance of their operations, maximizing the reliability of their assets, bringing agility into the plants and being able to manage some of that variety, safeguarding and assuring quality of what is produced, and at the same time making sure that they're able to meet all of their regulatory obligations. So collectively, those are the business outcomes or the customer imperatives around digital transformation. And fortunately, there's a number of technology trends that I show over on the right here that have come along kind of just in time to help manufacturers really affect those digital transformations and drive value from investments in those areas. So we'll dive in a little more into those technology-enabled value propositions, and we'll look at them kind of 3 or 4 of them. The first one, and probably the most commonly recognized one from a digital transformation perspective, specifically in operations, is around asset performance management. So it's never been easier to collect information around our assets and how they're operating. Traditionally, we've always collected information from our operating assets and equipment from a control perspective. So what data do we need to be able to control and run this asset productively? That's increasingly changing now with the cost of sensing and data collection is changing now to where data is now being wholesale collected around the operating state of the asset, and then that information can be used to look at the health of the asset as opposed to its kind of operational aspects. So there's a number of technologies get involved here. Oftentimes you'll see people pushing data, asset performance data, directly to the cloud, so not necessarily to a traditional kind of ISA level 0, 1, 2, 3, 4 type data structure, but pushed directly to the cloud. IoT technology, so a lot of what we call secondary sensing, so sensors that really aren't needed from a control perspective, but that are vital from an operational health perspective. That kind of data that can be collected directly from sensors on the machines and sent to the cloud or other places for later analysis. BPM is a business process management acronym. So this is really just a digitalization technology that's used to drive and govern kind of the actions of operators. Basically you capture the processes, the things that people do in response to events, and instead of leaving that to chance or to the experience of the operator, that gets driven through a digital system that then kind of assures the collaboration, can measure the various times that are involved. So in that example I used, talking about downtime events, for instance, if the machine goes down, how long did it take for a maintenance technician to go and inspect the piece of equipment and make a decision on whether or not it got restarted? How often did we have to escalate to a shift supervisor to get a maintenance technician there in a timely manner? So that's BPM technology. Mobility, again, as we increasingly push asset performance information up in the cloud, we want to access that not just in fixed workstations and panels down the plant, but on mobile devices, really anywhere where that data needs to be had. So for instance, maybe that asset health data isn't being kind of directly monitored by an operator on site, but is being monitored by the producer of the asset, the OEM equipment provider, who has a specialist team who monitors the health of those assets and pushes work directly into the plant if they see any anomalies in the operation of the asset. And then finally, big data. So big data is kind of a broad term. It really just refers to, in this case, there's an awful lot of asset health data that can be collected that, as I said, we traditionally haven't looked at because it wasn't control related, and that can bring some significant savings. So this particular value proposition, depending on the industry and the types of equipment you're looking at, can literally, we've had customers who are using the technology in this area that have saved multiple millions of dollars by avoiding, say, a major equipment failure on a large generator set, for instance, can save many, many millions of dollars. So another technology-enabled value proposition is what we call operations transformation, and this is essentially kind of a growth out of the long-standing trend to move towards the manufacturing operations management software. As we digitalize things, there's a number of these new technologies that can add some significant value to that. So again, cloud, secondary sensing, IoT, mobility, big data analytics, BPM, all of those kind of technologies can really help add value to the MES or MOM solutions that are in the plant today, and address, as you can see, a number of the business imperatives that we see customers driving to with digital transformation. Another value proposition is around traceability and quality. So talked about kind of some of those drivers, and we're all familiar with kind of recall stories and when things go kind of tragically wrong for a manufacturer, particularly if, industries such as automotive, food and beverage, or others, where a safety issue or a quality issue that gets out into the public and isn't caught and recalled and addressed very quickly, can cause some significant kind of impacts to those customers. So traceability is and quality kind of go hand in hand. Quality is obviously the collection and assurance of the quality of the goods that you produce. Traceability is really the information that supports that, and so we see a big value proposition as manufacturing customers look to engage their customers, the consumers, whatever those consumers may be consuming. Those consumers, there's real value add for them to be able to access information traceability and the desire for them to understand where those products came from. So if you pick up a can of baby infant formula, for instance, in the grocery store, so how do I know that's a real kind of Similac or whatever the brand may be? How do I know that's real from the manufacturer? How do I know it's not gray market, that it was stolen somewhere or fake? Someone put something else in the can, a cheaper brand or something, and just relabeled it. How do I get that confidence in the products that I'm buying? Traceability, consumer traceability can provide that level of confidence by allowing them to say barcode scan the barcode or the QR code on that can and see the history. So how did that can actually get manufactured? What was the plant? How did it move from the plant to where I am? If it's a fresh product, what was the cold chain to make sure that it was always maintained at the correct temperatures and it's fresh? All of those things, traceability and quality, there's a number of, again, technologies that address it. Obviously, mobility, big data, there's a lot of data that can be collected around not just the production of a particular finished good in a plant, but also the movement of the ingredients for that product or the components of that product and how it moved from production to the consumer. So a tremendous amount of data there. Again, need for collection of data, not just from the traditional PLC kind of infrastructure that we have in our plants, but also out through the value chain for the customer. Mobile access, obviously, if you're looking at people accessing data in a supermarket, say, they're going to be doing that on mobile. So another kind of what we call technology-enabled value propositions are in engineering efficiency, and this kind of covers a bunch of kind of I guess you call them non-functional topics around how the engineering and design of the assets and processes can be done, how operators can be trained. This is a particularly rich area for digitalization that we're seeing. So if you were to think about, say, a refinery or a new process unit going into a refinery, typically that process unit will be simulated first. So the process will be simulated as part of the design of that asset. That process simulation can now be used for a number of things, not just to verify the design or to set up the design, the physical design of the asset. It can also be used for training. So one of the areas where we see some pretty neat or cool digital technology being applied is taking these large process simulations that we have and visualizing them through virtual reality. So an operator can kind of literally, with a headset, step into a digital simulation of the plant. They can walk around it. They can be taught how to operate that plant or that asset safely in a digital environment, kind of like a flight simulator. So engineering efficiency, very big value proposition that we see being enabled through the use of digital technologies today. So having talked a little bit about the value propositions and where digital technology kind of enhances traditional kind of manufacturing software value propositions, moving on to some of the key elements of the solution. So EcoStructure as an architecture is a Schneider Electric kind of way that we talk about the architecture and the structure of the technology that we provide, and it really takes very kind of a, if I can say it, a Industry 4.0 type view of plant architecture, which is a little different to what's traditionally been portrayed, and really breaks down to three main levels. The connected things, which may be sensors, they may be smart machines, they may be smart devices such as drive controls and other things that are enabled with connectivity. Edge control, what happens at the edge. Edge is really where these connected products connect into the system. There's a series of apps, analytics, and other services that kind of spread between both in-premise, in-plant, and cloud implementations. And it's important to note that there's obviously been lots of hype about the cloud and its use in manufacturing and this kind of stampede to the cloud. Well, as it has always been really that the real move in the industry is not this movement to the cloud, it's a movement to the edge. And what we mean by that is that today our traditional manufacturing software is on-premise based. We certainly see a tremendous amount of value in integrating cloud for certain aspects of things, like analytics, for instance, like management of configuration, some of those other types of areas. But we also believe that there will always be a need, never say always, I guess, but there's certainly a need today. The critical, mission-critical, time-critical functionality has to reside at the edge, and will continue to do so for the foreseeable future. So what the cloud is doing from that perspective is not really kind of revolutionizing or completely disrupting the architectures that we do today. What it's really doing is enhancing and improving them and lowering the cost of ownership around that. So we'll dive into that a little bit. When we look at these smart connected operations, on the left side there, you'll see the traditional IFAS 95 kind of 5 levels, 1, 2, 3, 4, 5. And really now when we look at things, we cast this a little different in those 3 layers that I talked about. So at the level 0, 1, 2 is the traditional kind of, or the band of connected things, and I talked about what some of those may be, equipment, machines, instruments, sensors, etc. And then at the edge, where we have kind of those traditional types of assets that we've always deployed in our plants, so HMI skaters, PLCs. There's certainly a new generation of mobility and mobile clients that are deployed at this level now at the edge for operators and operations, and also a new class of devices which we loosely call edge devices, whose goal is really to provide connection, context, and filtering of data from the connected things and flow it back up into the rest of the application or the system. So that's kind of those first 2 levels, connected things, edge control. And then what we traditionally had thought of as level 3 now becomes, as I said, split between cloud and on-premise. Some of the same types of applications that we've traditionally done, NES, workflow, maintenance type apps, but now with a hybrid approach. Firstly, so things like maintenance apps that are extended through cloud or cloud analytics and reducing infrastructure needs in sites, etc. But also the cloud provides you'll notice on the left side here, there's another line that shows kind of in some cases, this is the secondary sensing that I talked about earlier. If we don't need to push signals, data signals up into our apps and for analytics, if it's not required at the control layer, we don't necessarily need to push it through that control layer. We can push data now directly up to the cloud and then using that same set of services that we show up there. So coming back to the digital transformation journey then, so each company kind of embarks on this, as they move up that digital maturity curve. And I want to start this topic really by just talking about the pillars of a digital strategy. So as I noted in that maturity model that I showed, one of the key kind of differentiators of how mature you are as a business in your approach to digital transformation is really around the strategy that you have and how pervasive it is. So is it a business-wide strategy that's been put together? And most customers that we work with who have a well-defined digital strategy for transformation kind of coalesce around these 5 main pillars. So empowering their employees, so unlocking kind of productivity, improving kind of the work experience, if you will, and really gaining the most that they can and providing the best that they can to their employees. Optimizing their operations. That one seems that's kind of where we go to first as manufacturing people. Always technology should help us to run our plants better. And that's certainly a big pillar of most companies, manufacturing companies' digital strategy. Engagement with your customers. So I talked about that kind of value propositions like consumer-based traceability, other types of work that's done, but the customers, as they move through and mature on this digital transformation, typically a major goal is to get closer to their customers. Food and beverage manufacturing is a great example. There's a whole retail sector that sits between them and their customers. What some of the technologies that we've talked about can promise is, if you're going to have a consumer, like I said, scan a barcode on a block of cheese or a can of baby formula or something to get information about that, that's a relationship. So for that to work, obviously the consumer needs to have an account with you. So now you actually have you know who your customer is, as opposed to just someone who bought some product off the shelf in a grocery store. You know where they are. You know they're buying pens. So how often do they buy their baby formula or their cheese? And it's a vehicle for kind of driving other kind of information. Certainly all the nutrition information can be passed down. In the case of food, you can pass recipe information, maybe suggestions for other foods. So if it's cheese, you could suggest maybe wines from your company's portfolio that pair well with it. So that kind of engagement with customers is a key vehicle for growth for a lot of manufacturers, and digital transformation for a lot of our customers is really around how do we better engage their customers. Transformation of offerings. So again, a lot of this speaks to the variety that I talked about. But a lot of customers are looking to really change the sorts of offers that they bring to their customers. So there's a number of kind of some very obvious disruptors. And one I like to use, not a manufacturing example, but taxis and Uber is a great example of a transformed offering that was brought about through digital change. And then finally adopting the business models, so whether that be on demand, where the consumers can, in the case of, say, a car, can go in and order the exact car that they want and have it built and delivered. That doesn't happen too much here in the U.S., but certainly it is done in Europe. Some of the more kind of enlightened and forward-leading automotive manufacturers, but there's a number of other examples you can give where companies look to really change how they do their business. And as business gets changed, as their business model changes, they need their manufacturing or their operational back end to be able to support it. So those are the typical pillars of a digital strategy. Like I said, the business outcomes I showed at the bottom range from kind of cost management, employee satisfaction, productivity, etc., manufacturing costs, so cost control, cost management, to revenue growth. So when you start to look at a business being able to adopt a new business model, have a transformational type offering, those things are all growth opportunities for those businesses. So that's kind of what a digital strategy looks like for many of our customers. And it's easy to imagine us as manufacturers to really be pigeonholed around kind of the only part or place that we have to play here is in this optimization of operations. But it's really not true. I put a bunch of different value drivers, kind of value propositions up there that an operations group can bring to a business-wide digital strategy in some of the areas that it affects. So engagement with customers, we already talked about traceability, but one of the other key customer satisfaction drivers is things like on time and full. So this integration of demand, planning, and execution at the manufacturing side to be able to deliver products to where our customers, or where your customers want them, when they want them, and as they want them, is a critical driver of customer satisfaction and engagement. Things like adopting, transforming offers, adopting new business models. We can bring shorter time to market for that. We can adopt into more demand-driven models where we're manufacturing to order or to demand, as opposed to simply producing to stock and doing changeovers according to some quarterly sales forecast that someone had. So there's a lot of the net of this slide is really that a well-executed digital transformation in an operational area in manufacturing can actually provide value and be part of many different pillars in a company's overall digital strategy. So we talked about the model. I showed it again here. Did want to talk a little bit about kind of some of the barriers to maturity. And, what kind of stops companies from just, hey, let's go do digital transformation today. And you can see that kind of lined out there. And certainly at the bottom, at the end of the scale, lack of strategy is kind of a key. Strategy in this case has to come from the top. So I've yet to see a digital transformation that is kind of bottomed up. Sometimes that's a useful approach as a proof of concept or something else. But it's really true transformation in business. As I said, transformation that touches technology, people, and processes really needs to be driven from the top down. That starts with a business-wide strategy. As those companies become more mature, the strategy gets refined and defined and driven through the business, and then some other things start to come up. So we don't have the right people as we implement more digital technology. We don't have the right skill sets. That might mean additional employees, different employees, or training and enabling your existing employees to deal with that transition. And then finally, as companies reach the higher levels of transformation and really start to be a driver of the business, other concerns such as security, cybersecurity is always a major concern today, both from a safety perspective, but also from a business perspective. If you go back and think about kind of things like customer engagement, and you look at the impact of some of the cybersecurity failings that have occurred over the years, might have had on you personally, credit card information got hacked or something like that. So as companies become more mature, technology, technology outcomes like cybersecurity have become increasingly important. So those are the main kind of barriers that we see that companies overcome as they mature. So I'm just going to step through a few kind of examples. I've talked a lot about transformation. I've kind of talked anecdotally about a few things, but I did want to talk about some specific kind of technologies and the application of them into manufacturing. This is really to kind of wet your whistle, as it were, or get you kind of excited about what some of the possibilities are. In general, these are all kind of real things. These are based on things that we do today with our customers. So these aren't kind of like, hey, maybe we could kind of go speculatively go look to do these. These are all things that are done today, and like I said, are in use by customers today. So I'll start with this notion of the digital twin. This very germane to the discussion that we had around assets and asset performance. So the concept of a digital twin is that it's a digital representation of the asset that really captures kind of its operating parameters and provides a digital view, if you will, of the operating asset. We take that a little further and we talk about the firstborn digital twin. And the idea of the firstborn digital twin is it goes back to, as I said, that notion of designing and simulating the asset before it's even built. And that provides kind of a great baseline data set for technology, digital technology that can be used later in the life of that asset. So we can predict how that asset should be performing and compare it to how it is actually performing. As I said, we can provide virtual reality environments to train operators on those assets. So we're literally letting operators walk around the plant, open valves, adjust set points, etc., and learn how to run that asset in the most efficient way. So that's firstborn digital twin. Data-driven maintenance, talked about this. These are kind of the levels that we see of maturity around kind of the approach to maintenance or preventative maintenance. Kind of every week I do something to my pump. Condition monitoring, so looking for things like, hey, there's a kind of a rising current in the windings. I'm taking more current into my motor than I usually do, so that means that there's something wrong and you need to go look at it. Predictive, which is really a longer horizon. So predictive maintenance really looks at the overall operating envelope of an asset, and statistically and through pattern recognition, machine learning, kind of models the operating envelope of that asset over many, many different operating conditions, and can provide alerts to say, hey, we're not seeing the asset react to its current operating condition the way it usually does. And then there's an analytics piece that goes on the back end of that. Once we detect that alert, that anomaly, to really drill in and come up with likely causes and needed actions. And typically that's a longer horizon thing. So it's kind of like, hey, you think within the next 6 months this asset could fail, so you better schedule a shutdown because we believe there's a crack in the shaft of the generator set or something like that. So, and then going all the way through the prescriptive maintenance that we talked about a little earlier. Workforce enablement. We talked about some of these virtual reality for training. So that's a kind of a screenshot of what an operator may see when he's walking around inside of his virtual plant. We can overlay all of the operating parameters of the equipment that he's looking at, and like I said, react to what he may do in a particular scenario or situation. So he opens the valve, the process simulation will show the impact of that on the process in a very obviously safe and secure environment. Excuse me. Operator maintenance, workflow execution. This is really just bringing mobility to the operators so that they spend less time in control rooms, more time out maintaining in the plant and maintaining or operating the plant. Closely related to the one on the right, which is augmented reality. This is another kind of exciting technology that's kind of here now. So we've been able to provide to operators, maintenance technicians remotely through mobile devices access to maintenance information. So here, I can look up the SOPs, I can look up the assembly instructions or maintenance instructions for a particular asset while I'm out there. Augmented reality really takes that one step further and uses locality, so the device, the tablet or wherever can know where you are in the plant, either through GPS, through barcode tagging or some other mechanism, so you know where you are. And it's almost like I want to say a Pokemon Go. It's just the best example I can think of, where we can overlay kind of maintenance procedures, operating procedures, and instructions onto the view that the operator sees through his camera. So you can't really see it in that particular screenshot over on the right, but you have customers that do just that. So kind of the maintenance technician, for instance, can look through his tablet at a piece of equipment and see the 5 bolts highlighted that you need to undo next to disassemble that and do some maintenance activities. Tremendously powerful for not just for maintenance, but also for sanitation. Anywhere where there's kind of mechanical procedures that have to be kind of executed on a what I would say a fairly irregular basis. So sanitation is a great example of that, where perhaps machinery has to be disassembled and deep cleaned, but that only happens kind of maybe twice a year or something. Obviously, regular cleaning happens all the time, but maybe the machines have to be disassembled, and maybe there are specific kind of areas that are very hard to sanitize that need special attention. So that kind of information can all be captured and highlighted to the users as they're doing those procedures. Cloud Machine Performance Metrics OEE. This is actually now an offer that we're just releasing, which is basically taking the idea of secondary sensing, capturing data directly on the machines. So these may be existing brownfield machines that weren't heavily instrumented. Like I said, they have enough instrumentation for control purposes, but not really for efficiency or OEE purposes. So you can add additional information or sensing to those lines. You can push that data directly to the cloud and then do performance metrics, KPIs, OEE, etc., up at the cloud level without having to put any kind of additional infrastructure on premise. So that's another kind of area where we're seeing kind of clouds start to move in certain areas. So that discussion I had around hybrid architectures very much applies here. OEE and KPIs don't need to be online all the time. They're not kind of operationally required to run the plant as such. So they're a great candidate to push to the cloud from that perspective. It's just kind of shows some of the machine models, et cetera, that are implemented as part of that cloud OEE solution. All of the data obviously is available through very thin client web browsing. Serialization, I talked about consumer traceability quite a bit. Serialization is kind of well established in a lot of manufacturing sectors, discrete manufacturing particularly. Kind of serializes high value components, has done for a long time. We're starting to see it really move now into the hybrid batch manufacturing and consumer goods areas. So unique serial IDs on medicines, drugs, and high value food items, so meats. Anywhere where really consumers have an interest in knowing the history of that particular product that's in their hand. We're seeing serialization as being a big technology for that. I just wanted to close with a couple of more customer stories. So we talked about New Belgium Brewing a little earlier. Talk a little bit about Quick Trip. So Quick Trip here in the US is a convenience store chain that's connected to gas stations. So Quick Trip is kind of the market, if you will, that's built into and coincides with the gas stations. They did a pretty significant visualization effort a couple of years back that they rolled out in parallel with their SAP deployment. It's a fully mobile solution, so they use this for all of their raw material receiving. So they actually manufacture 70-80% of all the food that they sell in their stores, their own brands. So they have kind of pizzas and frozen foods and that kind of stuff. So they have manufacturing facilities to do that. They mobile enabled their entire workforce. So mobile carts for receiving with scales, barcode scanning, bringing data down to mobile devices for the operators on the plant floor. In the U.S., there's similar regulations in the U.S. In Europe, but in the U.S. we call it the Food Safety Modernization Act, has certain requirements around not just the ability or traceability information that needs to be collected during the manufacturing of food items, but also the ability to access that information. So you can see that they brought down their traceability times to look up quality data and history on products that were made from a quality release perspective from 2.5 hours down to 10 minutes was pretty dramatic improvement for them. Another customer I like to talk about because it really does kind of flow into that digitalization theme that we talked about is Campbell's Soup, another customer of ours. Interestingly enough, they justified this system. They actually have a few systems from us, but this particular system is quality, kind of a quality data collection system that digitalized the QA in the plants. The justification for doing that was really based around their ability to continuously improve their processes in the plant. So they analyzed how much time their greenbelt spent actually trying to go out, collect and validate data, as opposed to analyzing and improving their processes. And they estimated that if they digitalized that quality system, they would be able to run through an additional 75 CI projects per year, with obviously some standard view of what a typical CI project would return to them in terms of value. And they really hit the big one. The first kind of application that they really went after with this was the product giveaway. So at the time, I believe it was a 5% giveaway that they had on their product. So they kind of put more product in the box than they needed to improve QA processes and the CI teams being able to use the data that's being collected. They were able to reduce that product giveaway by a quarter, which was a multi-million-dollar win for them. Enabled them to be much more consistent about the weight of the packaging, so that they were produced a lot less variability. That actually helped not just from a financial perspective, hey, we don't have to give away the product, but also from a process perspective, because now kind of the weight of the pallet was less variable, if you will. And so as there's kind of a ripple effect as it goes down through the supply chain. So that kind of finishes up the content piece of this. So we'll kind of move on to the question and answers. So I have a number set up in the console already. So we'll work through those. We're not going to. I can already see we have more than I'm going to be being able to address today. So we will kind of summarize all of the questions that we got and send out written answers for all of the attendees. The first question is around return on experience, what works well, what needs more attention to focus on. So from a digital transformation perspective, I guess one of my kind of key messages that I give to customers when I speak about this is change management is absolutely critical. So there's an awful lot of that we expect of our employees or the employees as the digital transformation takes place. Certainly we expect them to do things differently. We expect them to use new tools, new technologies they may or may not be familiar with. And so change management kind of, and again, this comes back to why I said the strategy has to be a top-down approach. Change management, helping enable employees to really leverage and use technology and deal with the changes that come through, absolutely critical. And some of that can be done by someone like us, a vendor of the technology and the solutions, but a lot of that has to come internally as well. So kind of plants have to be prepared for the changes that are happening. People need to be trained. People need to be made comfortable with the new processes and technologies that they have. There needs to be adequate support. All of those things fall on the change management. So to me, that's kind of where most of our customers kind of under-anticipate what's needed as they go into these kind of deployments or these kind of programs. Excuse me. The next question is, what are the best strategies for rolling this out across global manufacturing plants, different maturity levels? I think that's a great question. So as I said, change management is kind of the Achilles heel of some of this, particularly when you start dealing with a number of different plants, maybe a number of different regions. There may be cultural differences, language differences. So change management has to be very carefully planned for that. You also need to adjust kind of technology. So, for instance, I'll use the example of OEE as a case in point. Most customers or most technology providers in this area have been offering OEE, on-premise OEE solutions for many, many years, as do we. These are very kind of rich, full-featured systems that not only give you a number, an operational metric, but also provide a wealth of data about stoppages, analytic tools to really drill into root causes, etc. So that's great if you're talking about putting that into a plant in Europe, North America, where there's already a plant-wide kind of control network layer, an HMI SCADA that's connected, etc. You go to other, maybe less sophisticated regions, APAC, Latin America, Africa, where some of that infrastructure that we take for granted in Europe and North America may not be readily present and may be very expensive to deploy. So rather than have to do that, we can look to kind of shift the technology approach. And this is really where I'm getting to with the answer here, is to look at kind of what technology works best as plants move between, or as you move between different regions. So in the case of OEE, or plants in Europe and in North America, as an example, an on-premise solution that provides a lot of detail and a lot of data to CI teams might be absolutely the best solution. For a series of more manually operated plants across, say, Africa that are kind of less sophisticated, have less support infrastructure in the plants, maybe more of a cloud-based solution for OEE is more appropriate. The important thing is to combine those two in the context of a single program. So I think I have time for just one more question. Question here is, how about predictive maintenance based on historical data gathered by sensors? Any experience? So yes, so this is a big, it's probably the first of the kind of digital transformation IoT success stories, if you will, not just for us, but for other vendors in this space, is around asset health monitoring. So like I said, we absolutely have offers in the market today doing predictive analytics, collecting kind of lots of not just operational data, but also environmental and health data from assets, and bringing them into a predictive analytics engine that can not only kind of forecast or predict a potential anomaly in the operation in the future, but can also provide the analytics tools to derive a root cause and an action that needs to be taken. And like I said, some of these systems that we've deployed with customers have some huge ROI. One of our customers that I believe is pretty well documented is Duke Energy in the U.S., an energy producer, obviously. They've had, I believe, the number was $20 to $30 million of what we call catch savings. In other words, the predictive analytics platform caught anomalies in the asset operation that they were able to address and repair before they caused catastrophic failure. So they had a huge ROI on that particular system, that particular application. So predictive maintenance is one of the more mature offerings, I guess I would say, in the IoT space at least, around kind of secondary data collection and advanced analytics. So with that, we're a little bit over time. Thank you for everyone who hung in there with me for a few extra minutes. As I said, we will distribute a Q&A around all of the attendees, and I'd like to thank everyone for your time today.
Keith, thank you for your time as well, and thank you everyone for tuning in. The on-demand recording will be available soon, so keep an eye out for an email from us with the link. Until next time, goodbye.